Hi, this is Mrs. Rodrigues with your introduction to simple probability. So, probability is the likelihood, where's my pen? Likelihood of an event happening and is expressed as a number between 0 and 1. 0 being something is impossible and 1 being certain. There's a 100% chance that it's going to happen. So it says label the terms on the number line: unlikely, equally likely, impossible, certain, and likely. So we already did 0 and 1. That's going to be our impossible and our certain. So that means halfway between impossible and certain is equally likely, right? There's a 50% chance that it will happen and a 50% chance it won't happen. So this is like 50-50. So then if we have unlikely and likely, well, unlikely would be between impossible and our equally or 50-50 chance, okay? And this means, can it happen? Yeah, but is it going to happen? Probably not. And then likely, our last term, would be between equally likely, the 50-50, and the certain. Is it possible it'll happen? Yes. Is it gonna happen? Probably. I can't say for 100% certain, but it's probably gonna happen. Okay? So, read each example and label the situation with one of the terms above. Number 1, snowing when it's 40 degrees outside. Well, this is gonna be impossible because that's not cold enough for it to snow, so it can't happen. Burning your dinner if you cook it too long. Yes, that is likely. Is it for sure certain? No. You might cook it a little longer than you're supposed to and it could still be fine or maybe a little dry but not burnt, right? So it's likely but not 100% certain. Water boiling at 75 degrees. That's impossible because 75 degrees is not hot enough to boil water. Getting a ticket if you are speeding. That is likely. Is it going to happen? Probably, but will it for sure happen? No, there might not be any cops around that see you speeding. But there's a good chance you will get a ticket. 5, scoring from a safety in a football game. Unlikely. It's possible, but not very likely. Number 6, a coin landing on heads when it is flipped. Well, a coin has two sides. It has heads and it has tails. So when you flip it, it's equally likely, or you have a 50-50 chance. Okay? So simple probability. Simple probability is the ratio of successful outcomes to the total number of outcomes possible. So for an example, go ahead and cross out probability of A. The probability of getting heads when you flip a coin. Okay, we just did that in number 6. We said that a coin has heads on one side and tails on the other. So if I want to know the probability of heads, there is only one side that will give me what I want. So the number of successful outcomes would be 1. One side gives me heads. The total number of outcomes possible, though, are 2 because I have heads and tails. So it would be 1 out of 2, which gives us that 50-50 chance. So the probability of getting heads would be 1/2. The probability of the event not occurring is the complement. Okay, go ahead and highlight that, the complement. That means the opposite of a successful outcome, right? So something not happening. The probability of the event and its complement have a sum of 1, meaning the probability of something happening is 1 and the probability of something not happening is 0. So if you were to add those together, 0 and 1, you would get 1. And notice here, they have this little symbol that they put on the P to show that it's the complement. You have that apostrophe there. So go ahead, we're actually going to cross this out. We're going to use our example of heads again. So I'm going to put that apostrophe so we know it's the complement, the probability of not getting heads, okay? The probability of not getting heads. So once again, on our coin, we have heads and we have tails. So the number of outcomes we can have that's not heads is 1. Tails, right? There's only one side that's not heads, and that is tails. So that's going to be 1. And the total number of outcomes is going to be 2 because we have heads and tails. Okay? So the complement is 1/2. And if you were to add the probability of getting heads with the probability of not getting heads, you would have 1/2 plus 1/2, which equals 1. Okay. So now on your sheet, find a place somewhere on your sheet. Let's see. I'm going to do mine here. And we're going to put the probability of getting something is going to be equal to successful, help if I spelled it correctly, successful outcomes divided by total number of outcomes, okay? And that's going to be our formula for doing probabilities. Successful outcomes divided by the total number of outcomes. Okay. All right, moving on. Number 7, what is the probability of choosing a marble with stripes? What is the complement of choosing a marble with diamonds? Okay, so first we have a marble with stripes. So I'm looking on here and it looks like this has stripes. Okay, so there are 1, 2, 3, 4, 5 circles altogether. So the total number of outcomes that have stripes that would be successful is 1 because there's only one circle with stripes, and the total number of outcomes possible is 5. So it'd be 1/5. Now the complement, let's change the color. The complement of choosing a marble with diamonds. So the complement of choosing a marble with diamonds would be, let's see. This one doesn't have diamonds, this one doesn't have diamonds, and this one doesn't have diamonds. So the complement means no diamonds, right? Not possible, no diamonds. So the total number of circles that would not have diamonds is 3. And the total number of outcomes or circles altogether is 5. So it'd be 3/5. All right, 8. What is the probability of spinning a W? What is the complement of spinning a W? So let's choose green. So I look at my circle and I have 1, 2, 3, 4, 5, 6, 7 altogether. So I know the total number of outcomes is going to be 7. So that's going to be my number on the bottom. Now, for the probability of getting a W, I got to see, well, how many W's are there in this circle that would make it successful? Well, we have 1 there and I don't see any others. So that means that the probability of getting W would be 1 out of 7. Now, the second one says, what's the probability of not getting a vowel? Now, remember, a vowel is your your A, E, I, O, and U's. So I have to look and I have to go, okay, well, out of this circle, how many of them are not vowels? Well, H is not a vowel. A is a value, F is not, H is not, P is not, and W is not. So the total number of successful outcomes that are not values would be 5. And once again, the total outcomes possible is 7. So the probability of getting a vowel would be 5 out of 7. Read each of the problems below and determine the probability of each outcome. So you're going to do 9 through 14 on your own. When you're ready to check your answers, come back to the video. So go ahead and pause the video, do 9 through 14, and then when you're ready to see if you got it correct or not, go ahead and restart the video. Go ahead and pause the video now. Hi, welcome back. So number 9, a standard number cube is rolled. What is the probability of rolling a 6? Rolling a 6 would be 1 out of 6. There are 6 sides to a dice. There's only one 6, so it would be 1 out of 6. Of rolling a 5, well, there's only one 5 on a dice, and there's 6 sides, so it would be 1 out of 6 again. An odd number. Well, if there's 6 sides and we have 1, 2, 3, 4, 5, 6, an odd number would be 2, 3, and 5. So it'd be 3 out of 6. Number 10, a laundry basket has 24 socks in it. 6 were navy, 10 were black, and the remaining were white. What was the probability of drawing a black sock? Well, there's laundry baskets with a total of 24 socks, and there are 10 black socks, so it'd be 10 out of 24. But remember, when we're dealing with fractions, you should simplify them if you can, right? You're expected to simplify. And I know that 10 over 24 can be simplified because they're both even numbers. So if it's an even number, I know that 2 goes into both, and my answer is going to be 5 over 12. Now, for a white sock, well, we already know the total possible outcomes, right? The total number of socks is 24, so that'll go on the bottom. So now we need to see how many of them are white out of the 24. Well, 6 are navy and 10 are black, and the remaining are white. So I'm looking at this. So that means 24 minus the 10 black would be 14, minus the 6 that are navy would be 8. So we would have 8 over 24. Once again, they're both even numbers, so we need to simplify, and because they're even, I know 2 goes into both. 2 goes into, or actually, we could go bigger. 8 goes into both, so let's go ahead and divide by 8. 8 goes into 8 one time, 8 goes into 24 3 times, and we get 1/3. Okay, the probability of getting a navy sock. Well, there's 24 total socks, and out of the 24, 6 of them are navy. Once again, we need to simplify. I know 6 goes into both, and I get 1/4. 11, the spinner below is spun. What is the probability of spinning not a 6? Well, first of all, there's 1, 2, 3, 4, 5, 6, 7 numbers it could land on. So the total number is 7. Now out of that 7, how many of them are not 6? Well, it looks like there's only 1 6 on the spinner, so that means there's 6 out of 7 that are not the number 6. A 3 or a 4. Will I have 1 3 here and 1 4 here? So that would be 2 out of 7. And last but not least, rolling an odd number. So let's see. An odd number would be 3, 5, 7, and 1. So it looks like we have 4 out of 7. 12. The letters in the word soccer are put in a bag and drawn randomly. What is the probability of choosing a vowel? Now, remember, a vowel is going to be your A, E, I, O, U. So we have 2 of them. There are 1, 2, 3, 4, 5, 6 total numbers, and 2 of them are vowels. So we have 2 over 6. They're both even, so I know 2 goes into both, and we get 1/3. A constant. Well, if a vowel's A, E, I, O, U, then a constant would be your other letters. So that's going to be everything else. Your S, your C's, and your R. So once again, there's 6 letters total. And out of the 6, 1, 2, 3, 4 of them are consonants. And they're both even numbers, so we know 2 goes into them. And you end up with 2/3. And then we have, what's the probability of getting a C? So let's do this one orange. Well, there's 2 C's out of 6 numbers. Once again, both even, so we can divide by 2, and we get 1/3. 13. At the pediatrician's office, patients are able to draw a toy from the toy bin. The toy bin has 12 puzzles, 16 boxes of crayons, and 2 bouncy balls. What is the probability of drawing? Okay, so first of all, we need to know the total number of prizes. So we have 12 puzzles plus 16 boxes of crayons, that's 28, plus 2 bouncy balls, that's going to be 30. So our total number is going to be 30. So I can already put 30 on the bottom for each of these. Okay, now anything but a bouncy ball. So out of the 30, 2 of them are bouncy balls. That means 28 of them are not bouncy balls. Both numbers are even, so 2 goes into them, and we get 14 out of 15. A box of crayons. Well, there are 16 out of the 30 that are boxes of crayons. Once again, they're even numbers, so I know that 2 goes into both, and we get 8 out of 15. And puzzles. Well, there are 12 puzzles, so out of the 30, 12 of them are puzzles. Once again, both even numbers, so they're divisible by 2. 2 goes into 12. 6 times 2 goes into 30, 15. I know 3 goes into 6 and 15, so we end up with 2 out of 5. 14. In the movie drawer, there are 7 action movies. So we have 7 action movies, 5 comedies, and 3 dramas. What's the probability? Well, first we got to see how many total movies. So 7 plus 5 is 12, plus 3 is 15. So now our total is going to be 15 possibilities on the bottom. 15 total possibilities. So the probability of getting a drama, well, there are 3 dramas, so it'd be 3 out of 15, which could simplify to 1/5, right? Because 3 goes into both. The anything but a comedy. Well, out of the 15, 5 of them are comedies. So anything that's not a comedy would be everything else. That'd be 10 out of 15. I know 5 goes into 10 and 15, so I'm going to divide by 5, and I get 2 over 3. And then the probability of an action movie. So there are 7 action movies. So out of the 15, 7 of them are action movies. And it can't be simplified, so we're all done. So go ahead and pat yourself on the back if you got 9 through 14 correct. Answer the question below. Students standing in line for lunch were surveyed about their favorite meal. Their responses are shown below. If one student is picked randomly, then which of the following is true? A. The student's favorite meal is half as likely to be pizza than spaghetti. Well, that's not true because 26 kids liked pizza and only 8 liked spaghetti. So they are not the same value, right? It's not a 50-50. So that can't be true. B. The student's favorite meal is more likely to be fajitas than pizza. Well, that's not true because 16 kids like fajitas and only 8 like spaghetti. So half the number of kids would like spaghetti or I'm sorry, we're looking at fajitas and pizza. So no, it would still be incorrect because only 16 kids liked fajitas, but 26 liked pizza. So kids like pizza more than fajitas. So that's not going to work. C, the student's favorite meal is twice as likely to be spaghetti than pizza. No, because not even half, like a little more than a third of the kids like spaghetti, but most of the kids like pizza. So twice as many that like spaghetti over pizza, it would have to be twice as many kids like spaghetti than pizza. And if 26 kids liked pizza, that means we would have to have like 52 kids that like spaghetti, and we only have 8. So that's not going to happen. So that means this last one, I don't know why the D didn't show up, but I'll go ahead and write it in. This one must be correct, but let's go ahead and check it anyways. It's likely to be fajitas than spaghetti. Well, 16 kids like fajitas and only 8 like spaghetti. So is it likely that they'd like fajitas more than spaghetti? Yes. So it's going to be D. Use the spinners below to determine the probability of each of the events. All right, so the probability of red. And I forgot to mention this before, but notice, oopsie, that was the school bell. Notice that when they write what's the probability of red, they write it with P and then what we're looking for in parentheses. This is a shorthand way of writing what is the probability of something, because it would be really a pain to have to write that out, right? Every single time you had a problem, if you had to write if you had to write for every single problem, what is the probability and it takes up a lot of room, it wastes time, so that's why they came up with this shorthand way. So anytime you want to know the probability of something, you just write a P and then parentheses, and whatever you want to know the probability of goes inside the parentheses. So if we want to know the probability of getting heads or tails, when you flip a coin, you would write heads in the parentheses. If you want to know the probability of getting tails, you would write tails in the parentheses. So it's just a shorthand way of writing the probability of, or what's the probability of, to save time and space. All right, so for number 1, the probability of getting red. First of all, we need to count what our total number of outcomes that are possible. So we have 1, 2, 3, 4, 5, 6, 7. So there's 7 possibilities total, or outcomes total. So now we need to see how many of them are red, and I only see this one, so that means 1 out of 7. For number 2, the probability of getting green. Well, we already know that there's 7 total, and we just need to see how many of them are green, and I only see this one is green, so it's going to be 1 out of 7. Okay, the probability of getting blue or red. So now I gotta look and I gotta see, well, here's blue. Oops, here's another blue. And here's a red. So out of the 7 total possible outcomes, 3 of them could be blue or red. Go ahead and pause the video. I want you to do 4 through 12 on your own. And then when you're ready to check your answers, go ahead and restart the video and see if you got them right. Go ahead and pause the video now. Welcome back. Okay, so we were on number 4, the probability of getting yellow or blue. So we know that there's the total number of 7, and the probability of getting yellow, well, here's a yellow here, here's a blue, and here's another yellow. So that means out of the 7, 4 are yellow or blue. The probability of not getting green. Remember, this apostrophe means not getting green. So That's a green, so this is not green, this is not green, not green, not green, not green, and not green. So out of the 7 total outcomes possible, one of them is, one of them is green, so that means the probability of not getting green is 6. There are 6 of them out of the 7 that are not green. Okay, now we have the probability of not getting purple. So let me go ahead and erase this. Okay, we know that there's 7 possibilities total. So the probability of not getting purple, well, this isn't purple, nope, nope, that is, nope, nope, and nope. So once again, it's going to be 6 out of the 7 are not purple. Moving on to the next spinner. Once again, we have to count how many total possible outcomes. We have 1, 2, 3, 4, 5, 6, 7, and 8. Now we're ready to begin. The probability of getting odds. Well, let's see. 3 is odd, 5 is odd, 7 is odd, and 1 is odd. So there are 4 out of the 8 that are odd. And we can simplify this because 4 goes into 4 and 8, and we end up with 1/2. So half of the spinner is odd, so you have a 50-50 chance or equally likely probability of getting an odd number. All right, so the next one says, what's the probability of getting evens? Well, sorry about that, so many school bells this morning.